We're so glad that you could join us this evening. My name is Erich Reed, and I'm the director of the Southwest Harbor Public Library. And I'm excited for this opportunity to introduce Professor Sean Todd tonight. This event is in partnership with the Camden Conference, whose theme is the Geopolitics of the Arctic, a region in peril, which culminates with live streaming events on February 20th and 21st. The Camden Conference was founded in 1987 as a nonprofit, nonpartisan educational organization whose mission is to foster discourse on world issues. Before I introduce Professor Todd, I'd like to go over just a few housekeeping items. We will be recording this event, and if you have any questions during this presentation, which we definitely expect you to have some, please submit them to the Q&A feature, which you can find at the bottom of your screen, just left of the middle. Staff member and library archivist Elliot Santavica will direct them to Sean at the end of the presentation. Professor Todd holds the Stephen Katona Chair in Marine Sciences at the College of Atlantic. He's received a joint honors undergraduate degree in marine biology and oceanography from Bangor University in the United Kingdom, and his master's and doctoral degrees in biopsychology at Memorial University in Newfoundland. He's also the director of Allied Whale, a marine mammal research program. Professor Todd is widely published academically, and his work has been also featured on the BBC, CBS, PBS, and NPR. And recently, he's the author of a great courses offering life in the world's oceans. Please join me in warmly welcoming Sean Todd.
Well, good afternoon, everyone, and thank you so much for agreeing to spend what is probably a significantly zoomed out day that you're going to do some more Zoom for the next hour or so. So thank you for that. I really, really appreciate it. I'm just going to check in with Elliot to make sure that currently you're seeing my presentation. Elliot, is that up and running?
Everything looks good.
Excellent. Great. Okay. So yes, I'm going to talk to you about some of the work I do down around in the Antarctic, and also some of my work up north as well. It struck me that when I heard about the conference that was going to be happening, the Camden Conference this year, that I had some unique experience perhaps to share, in that I've worked at both ends of the planet. And in doing so, have learned a lot about the ways that are similar and the ways that they are quite dissimilar from each other. So this talk is intended as essentially a primer for anyone who is interested in going on to the Camden Conference. I will not pretend to be an expert in anything that they're going to be speaking at that conference. You know, as you know, the main topic of that conference is going to be geopolitics. But I certainly want to give you a good base understanding of the area that they're talking about, why it is different to the Antarctic, and introduce you to some concepts that hopefully by the time you get to the conference will sound reasonably familiar to you. So in the course of the talk, I'll quickly introduce who I am and what I've been doing for the past 30 years or so, and then get specifically into physical, biological, and cultural history, governance types differences between the two areas, and hopefully show you some different images of the places I've been going. So who am I? I've been involved in marine research now for just over 35 years. I guess you would call me a marine biologist. I do specialize specifically on whales, and within whales, I specialize mostly on humpback whales. It feels like I've been working with them all my life. And so generally my job takes me to places where there are humpbacks. And so if you were to look at my resume, you will see that most of the places I've gone to are places where there are typically humpback whales. I'm also a professor at the College of the Atlantic, just down the road here from Southwest Harbor in Bar Harbor. And I've been a professor there for over 20 years now. And I know that my president, Darren Collins, would very much like me to quickly mention that the college, of course, is currently in its 24-hour fundraising event. So if you're interested in donating to the college, today is the day to do it because your funding gets matched. And I've been doing polar guide work since the mid-90s. And the reason I've been doing polar guide work is, first of all, I enjoy it. I love doing it. It takes me to places where I've never been before. But it's also a really sneaky way for me to pay for my research. Working on the water is typically very expensive to do. And if I can convince a couple of guests to come along with me and help pay for the boat ride, then in that way, I get to do my work. I get to talk about science with my guests, and hopefully help them understand a little bit better about how the world works. And yeah, we get to see and share some neat experiences together. So yeah, why do I go to extremes, as Billy Joel once said? It's mostly about these guys. These are humpback whales. They are a medium-sized baleen whale, probably something in the order of 35 to 50 feet, depending on their age. And they are the only species in their family that have these extraordinarily long, typically white flippers that give them then their Latin name, Megaptera, mega meaning large, ptera meaning wing, so large winged. Their species name after Megaptera is Novianglii, New Englander. So if you're watching this from a spot in New England, this whale was named after your region because the people who cared about such things and were originally hunting these animals got to name them. So this is the big winged whale of New England. But they do go down to the Antarctic, and they also go up to the Arctic, and so I follow them. The kind of work I'm specifically doing is I'm looking at whale tails. Most of you know that when a humpback whale lifts its tail out of the water and you look at the ventral side, the underside of the tail, the pigmentation patterns are unique to that individual. It's essentially an identical concept to that of a fingerprint of a human. So if I can take a good enough photograph of that region, then that allows us to match it to a catalog, which is kept at the college. College of the Atlantic has quite the reputation in terms of whale research, and we house several catalogs of many thousands of images of thousands of different individual whales. And so this is, a potpourri of shots I've taken down in the Antarctic. And just something for you to note, if you look at some of these images, you'll see that some of them are quite orange in nature. And that orange is not actually part of the whale. That's part of an algae, diatom algae that lives on the underside of the whale's tail there, because it's a sign of how rich the water is. Antarctica and in general the poles in general are incredibly rich areas of life, and that's why the whales go there, because they've got to eat. And so this orange pigmentation on the underside of their tails is kind of a sign that they're feeding in very rich waters. The kind of data that I collect, when you associate that with GPS tags and so on, can be used scientifically to understand how the animals are distributed and how they move. And these data are absolutely essential when we think about how to manage these whales, because they are protected depending upon which population you're talking about. So here you can see, this is the Antarctic Peninsula, which is an area that I typically work in. And there are two breeding populations on either side of South America that go down to the Antarctic Peninsula to feed. And those are the animals that I'm working on principally. Looking closer at the Antarctic Peninsula, and this is the work of one of my graduate students, one of my former graduate students, Maddie Kellett, where we can see here my photographs allow her to create a heat map, which is illustrated in two different ways in these two different panels, of where we might expect higher concentrations of whales. And again, those data are incredibly important because it allows us to think about ecotourism traffic down in Antarctica. Ecotourism is becoming much more prevalent in the Antarctic, and ships, if they're not regularly monitored, have the potential to hit animals. So you have to be careful about that. Another reason I go down there is because it's very challenging. I took this photograph a couple of years ago in the middle of a blizzard. I was on an island with some guests, and this blizzard blew up out of nowhere, which is absolutely what can happen down there. The weather conditions can be very challenging even during the summer, which is when I'm there. And this blizzard reached hurricane strength pretty quickly and made things very difficult for us. And here I am photographing a group of Antarctic fur seals who are just quite happily passing the time of day and not being affected by it whatsoever. So it's kind of fun to share this place with other mammals that are very, very well adapted to the environment. And of course, it's both poles are a place of extraordinary history. This is a shot of Ernest Shackleton. You see inset there. I'm sure you've heard of Shackleton's story. If not, I'm happy to tell it at another time, perhaps. And this is a photograph taken by Frank Hurley as Shackleton attempts the journey from Elephant Island to South Georgia in a modified lifeboat to save his men. Quite extraordinary stuff and very, very inspirational. But perhaps the reason I'm always going back to the poles is for this quote here. The first time you come down for the adventure, the second time you come down for the friendship, and the third time because you just don't function anywhere else anymore. And that has been particularly true for me this winter. Of course, this is the first winter I haven't gone down in many, many years because of the COVID pandemic. And I can tell you there are a lot of lost polar guide souls out there who did not get their polar fix this year. And you know, the poles really do grab you in some unknown way. And this is a picture of the team I work with. If you look carefully, you might be able to spot me. And here we are on the sea ice, celebrating the end of a very successful season. So let's get into the meat of the talk. Hopefully I've convinced you of my qualifications. We'll start with the physical and the oceanographic. We talk about the polar region as being these two places at opposite ends of our planet at the very end, the very extreme. I'm sure when you think about the word polar, you think about the word cold and you think about snow and ice. And that's generally true for both polar regions, but not totally true. It's also really useful to think of one of the big differences between these two areas is that Antarctica is a continent, and that continent is surrounded by a water mass, and that water mass is really, really important or that set of water masses actually is really, really important in keeping the weather into Antarctica and keeping it cold. So it's a continent surrounded by an ocean, essentially. That is converse to the Arctic situation. The Arctic is actually an ocean. When you think about that, the Arctic as being ice and snow, it's actually frozen sea ice, or not, as the case may be, given climate change. But it's frozen sea ice that represents most of the Arctic. It's an ocean that has frozen. And that ocean is surrounded by different land masses. So they have two very different identities, and that's going to turn out to be really important in terms of biology, in terms of oceanography, and actually also really important in terms of governance and culture. So here's a quick map of the Antarctic. You can see here the South Pole, obviously at the center at 90 degrees south precisely. And then ranging out from that, eventually you get to the Arctic Circle, which is at 66 degrees, coming around here. And you'll see that most of the Antarctic is inside the Arctic Circle, but there are a few places that are notably are not in the Arctic Circle, including certain parts of the so-called Antarctic Peninsula up here, which is where I do most of my work, which is the nearest spot to other landfall, i.e. South America. And in between the two, we have the Drake Passage, named after Sir Francis Drake. The South Pole is the South Geographic Pole at 90 degrees, but there are two other poles you need to consider. One is the pole of inaccessibility, which is the place that is the most distant to get to from any one shoreline. So that's roughly here. And then finally, we have the geomagnetic pole. We now know that true south, magnetic south is in a different location to true south, just because of the variances of our magnetic fields. I talked earlier on about the importance of the ocean around Antarctica. This is a heat map, and you can see through the color coding here that the ocean temperature around Antarctica is quite homogeneous, it's quite similar until you get to a certain point, and then all of a sudden it starts to change very, very rapidly. The interface between those two color layers, oceanographers would call a front, and it's called the Antarctic front or the polar convergence. And it is extremely important in keeping certain waters of the Antarctic close to Antarctica, and therefore keeping Antarctica very cold. Just some quick facts about the actual landmass of Antarctica. It's quite large. Some people, don't really think about it this way. It's actually larger in area than the contiguous United States by quite a bit. I think the contiguous United States is somewhere around about 9 million square kilometers. So it healthily beats that. Most of that is covered by an ice sheet or an ice cap, and that ice cap can vary in depth, but is on average around about 2 kilometers thick. And it's holding about 90% of all of the ice on this planet. Just think about that for a second. That's a lot of water, okay? And that, together with all the currents and the cold air that Antarctica produces, it's really one of the main climatic engines that we have on our planet. So you start changing that through anthropogenic influence, we're going to have a dramatic impact on what the world's climate would be like. That ice sheet expands and contracts according to the season. Of course, the seasons in the southern hemisphere are reversed to those in the northern hemisphere. So during the austral summer, the ice sheet is at its minimum, but during the austral winter, which would be around about August, September, that ice sheet extends out significantly, adding another 20 million square kilometers of surface to the area, and that would be sea ice. And we're going to be talking about the differences between sea ice and land ice in a minute. It's also the place where we recorded the coldest temperature on our planet, which is just stupidly cold, around about minus 90 degrees Celsius. The last thing is that, and this might surprise some people, technically Antarctica is a desert. So if you measure Antarctica by the amount of precipitation that it gets on average across the entire landmass, which is huge, it turns out that it gets an extremely low level of precipitation. Now, I know you like to think of Antarctica being about snow and ice, but all that has happened before. Now, currently, there is very, very little precipitation going on, the exception being the Antarctic Peninsula, which has more of a maritime climate. So here's a quick animation of how that ice sheet expands throughout the year. So you can see it's a very, very dynamic environment, and that in itself makes it very, very difficult to manage because it's constantly shifting from year to year. Now we'll turn to the Arctic. So again, you can see that the Arctic is mostly ocean. So I'm kind of tracing the area of the ocean here, the Arctic Ocean, and it is infringed on by a variety of countries that extend sovereign territory into the Arctic Ocean. So it's an ocean surrounded by land. That sets up a very, very different system. We don't really have time today to talk about the complexities of the oceanography in the basin, but suffice to say, it is fairly complex, and actually surprisingly little water leaves the Arctic compared to the Antarctic. Its surface area of the ocean is even greater than Antarctica, and it's made mostly of sea ice. Now that's going to be different to the Antarctic. Antarctic ice comes mostly from snowfall landing on the continent itself, that snowfall getting compressed into layers of ice, and that ice eventually becomes glacial and then flows back down to the ocean. So the icebergs that you see surrounding Antarctica are typically mostly fresh water because they're formed originally from snowfall. That's in contrast to the Arctic Ocean, where the ice is mostly frozen ocean. So that's different again. There's only one really significant landmass that's inside of the Arctic Circle, again at 66 degrees north, and that is Greenland. And Greenland does have a significant ice cap, and it's the main producer of icebergs going into the Arctic Ocean. Lowest recorded temperature, not as cold as the Antarctic, and that's partly because it doesn't have that surrounding ocean to keep everything cool. And also, it does lead to the geographic state of the Arctic does lead to some complexities in how we define what the Arctic is. With the Antarctic, it's reasonably easy. It's a continent, and its boundaries extend to the edge of the continent. Some people choose to actually oceanographically define Antarctica as everything out to and including the polar convergence, the Antarctic convergence I was talking about earlier on, that oceanographic phenomenon. But the Arctic is a little bit more nebulous because it consists of both ocean and land. It's no obvious place to redefine what it is. And that could be a challenge for governance because, as you know, politicians like to plant red lines in the sand. And it's difficult to do that when you can't define what that area is. You do, of course, get plenty of ice in the Arctic, and this is an iceberg I photographed in the Canadian archipelago up north. But a lot of the Arctic, certainly during the summertime, is not covered by ice or snow. It just looks very, very barren. It's extremely cold. It's very difficult for plant life to grow there. But if you look at a micro scale, the plant life is absolutely beautiful. And it has a very, very short, very intense growth period when there's enough sunlight and there's enough warmth. And when the substrate has thawed enough for life to happen. And then, of course, the seasons turn, it gets cold again and everything has to shut down. The formations in the Arctic can be absolutely stunning. Again, this is a shot, again, taken up in the Canadian archipelago. And you can see in front here, we have a glacier coming down. This is what we call the Ablation Zone. You can see how crevassed the front of the glacier is. That's because this ice is traveling towards the ocean. And as it meets the ocean, it becomes very, very stressed and breaks and cracks into these large crevasses, and eventually icebergs form. But behind that, check out this completely unsnow-covered, very impressive mountain that anyone into sedimentology and sediment geology would be freaking out over. And just absolutely amazing stuff. Quick word generally about oceanography. In the Antarctic, we have one current that goes all the way around the planet and continues like a giant cog. And that leads to what we call the Antarctic circumpolar current. That's this mass of water that's going around the Antarctic, sealing everything in. Now, contrast that to what's going up in the Arctic. We have we have two inputs. We have one input up here in the Bering Strait, bringing water in, not really any water coming out of any significance. And then in the over on the Atlantic side, we have the North Atlantic current. That's the main input of water into the Arctic. And then also the main exit for water out of the Arctic in the form of the East Greenland current. Looking at the polar convergence in more detail. So this is the snapshot of what's happening much closer to Antarctica. What is the details of that current that keeps in the cold and keeps Antarctica as a discrete unit in terms of climate? This is a cross-section of that basin that you might imagine. So here is the side of the Antarctic continent right here. And then we have the basin that will eventually connect to places like South America and South Africa. And you can see that it's actually pretty darn complicated. There's all kinds of different bits of water that are flowing from different areas, mixing, forming fronts, and so on. So it's actually pretty complicated. The really important one, and I'm just going to skip through this animation a little bit here, just to show you this area here. This is the Antarctic convergence. And the thing about fronts is because they represent areas where the density of water changes really, really rapidly, it tends to be a focusing mechanism for very small creatures such as plankton. So you'll find that if you were to record plankton along a gradient going this way towards the Antarctic, there'd be a huge spike here of plankton gathering at the convergence. And it turns out that the rest of the ecosystem knows that. So around the convergence, you'll see higher populations of seals, whales, seabirds, fish, all feeding on this plankton that's been forced into this one location. And then eventually humans found out about it, and that's where all our whaling occurred. When you hear about the great whale hunt of the 19th and 20th centuries, it was happening down around the Antarctic convergence, which is one of the few places on the planet that can sustain such huge populations of whales, which of course at this point have been mostly whaled out. Here's a picture of Arctic circulation. Again, this very, very dissimilar to what's going on in the Antarctic because it's interrupted by a whole bunch of land masses. That doesn't happen in the Antarctic. You've got free water all the way around. So you can see there's a series of circular currents. We call them gyres in oceanography. Here's the elastic coastal current coming in from the Bering Strait. The main input, though, is again through the North Atlantic current coming into the basin. And, you know, there's various, again, mixings happening in this area here. We'll talk quickly about ice as well. Ice is really important. This shot here is a shot of a celebrity iceberg that broke away from the continent of Antarctica maybe 15 years ago. When icebergs are sufficiently large that they can be severe navigational hazards, they are named, but they're named very unromantically. So the first letter in the name is the ice sheet, which this one came from. In this case, the letter B, because it came from ice sheet B. And then it gets a number after that, which is, you know, just a sequential number of how many bergs have split off from this particular sheet. So this one is B17. And then it gets a letter after that, which represents which fragment of that iceberg is it. So this is B15J, and it is about 60 miles long. It is absolutely huge. We brought the boat all the way up to it as safe as we could, and you could not see the end of it from horizon to horizon. Very, very impressive beast indeed. And when you have ice on that kind of scale, there's not much you can do. And part of going to the poles is kind of surrendering to some degree a little bit of your fate. You know, the weather and the ice will do what it will do, and you just need to be prepared to cope with those changes. So where do these icebergs come from? As I mentioned before, in Antarctica, a lot of the ice is freshwater ice coming from the ice sheet itself. So this is a cross section of the Antarctic continent from west to east here along this line. You can see the actual bedrock below is quite far beneath. Remember my earlier fact slide that the ice sheet is about 2 kilometers thick on average, but it can be as much as almost 4 kilometers thick in certain areas. So just imagine that, 4 kilometers of ice above your head were you to stand on the bedrock here, which of course you can't do, but we can drill down that far. And we're actually discovering now that there are lakes of liquid water held in some of these troughs and basins, which are just fascinating areas to study. I should mention that none of the photographs in this presentation have been altered color-wise. They're all the same. They are as my camera took them. And you know, the colors of Antarctica are astonishing. Probably one of the biggest surprises I had when I started working in polar regions was the colors. It's not all white at all. Sometimes you get these most amazing deep, deep blues. The blueness of ice comes from how old it is. The older ice gets, the bluer it gets. Because as ice gets older, it gets more compressed. And tiny particles of air get extruded from the ice as that happens. And so that changes the refractive index of ice, so it appears more blue. The layers that are less compressed have more air in them, and so they appear more white. So when you see deep, deep blue ice, you know it's super old, and you know it's very, very hard. Here's an image of what glacial flow looks like in Antarctica. So this is color-coded by speed. As you go from yellow out to blue, you start to get faster and faster. So some of these speeds are pretty fast for glaciers, but nonetheless, most places that you go to in Antarctica, glaciers appear to be retreating. Certainly, I've gone to many places repeatedly, and I'm starting to see places where they're now bare rock instead of the ice that I saw there before. When you get to the edge of a glacier, this is a tidewater glacier, you then get to this very, very crevassed ablation zone that I showed you in a shot previously. And if the glacier is active and still moving, then you get calving events. These calving events can be absolutely spectacular. I've turned the volume off on this video simply because the guests that were with me were shouting very inane things when it was happening. So I thought I'd keep that off, including a few expletives. It's very impressive when you see it happening. Does that happen in the north? Yes, absolutely. You can go to Alaska, you can see glacial activity. The biggest source of glaciers, of course, is Greenland. And again, a similar heat map showing the speed of how fast these glaciers are moving. And places where you see this red or purple color, these are areas that you would expect to have a lot of active carving of ice into the ocean, creating these icebergs. And about halfway up Greenland, you have Disco Bay, Disco spelled with a K, and that is a massive generator of icebergs. In fact, it's probably a fairly good bet that the iceberg that sank the Titanic off Newfoundland probably came from Disco Bay in Greenland. A little bit about iceberg terminology. There's some weird words involved there. Icebergs is anything bigger. An iceberg is anything bigger than your house. A bergy bit is anything between a house and a car. Smaller than a car, you have something called a growler, so named because it makes a growling sound as it scrapes along the side of your wooden hulled ship. Of course, we don't really use wooden hull ships that much more, but then nonetheless, when you hear ice going down the side of the ship, it's very, very unnerving, even if you're in a steel ship. And then finally, you have brash, which is this very sort of broken up ice, chunks of ice the size, anything from a foot down to the size of your fist. So just some images of what those look like. This is a bergy bit with a bunch of penguins on it, and then going down to a growler. And then finally this brash ice, which can extend for tens of miles, hundreds of miles past the region. And it's still very difficult to navigate. Any one of these chunks can easily shear your propeller. Moving on to sea ice. So far we've been talking about freshwater ice, ice that comes from icebergs, glaciers, and so on. Sea ice is when the ocean gets so cold that it starts to freeze. Now remember that that salt water contains salt, so that allows it to get much colder than 0 degrees before it starts to freeze. So typically around about -2 Celsius or so, you'll start to see this kind of gray slurry on the surface of the ocean, which if you inspect it very carefully, is a thin film of ice, but it's bendable. It's not fixed in the same way that freshwater ice is. If you let that continue, then you start to see the formation of what we call pancakes. And these pancakes can be quite large. And as they move up against each other, they start to rub up against each other, and you get these, like kind of these eroded edges. So you start to see this buildup of ice around the rim where it's smacking into other ones. And sometimes these ridges can be absolutely huge. Here's a ship for scale. This is one of these erosion ridges between two very large pans of ice. And then if you allow that to happen over multiple years, the ridges can be quite significant indeed. So in frozen ocean world, in sea ice world, we talk about single year ice, which is formed and gone within a year. And then we talk about multi-year ice, where it's so cold throughout the year that it actually grows and deepens and thickens over the years. And that can be extremely challenging. It was multi-year ice that Shackleton got stuck in. And once your ship gets stuck in multi-year ice, there's very little you can do unless you're an icebreaker. And even then, there is some ice that not even icebreakers can break. Frozen ocean is quite walkable on. So here I'm leading a party across the frozen ocean, and it's quite safe. Of course, if it gets too thin, you don't want to be anywhere near it. But in this particular case, this was multi-year ice that had been around probably for 4 or 5 years, nice and thick, probably around 3 meters thick, quite easy to walk on. And when I see this shot, I think about Mainers walking on local ponds and sort of thinking about the similarities of that. Here's a similar shot of frozen ocean in the Arctic instead. And if you look very carefully, this is one reason why you maybe not want to do the same thing. You not want to walk on frozen ocean in the north because of this guy right here. That is a polar bear. And that is, one of these big biological differences between the two. And that's a nice segue to thinking a little bit about the biology of the two areas as well. So when you think about these areas, they are intensely cold, obviously. They're cold primarily because They don't receive anything like the same sunlight energy that the rest of the planet does, because most sun at that angle deflects off the atmosphere. And also they're cold because they are predominantly white, and the color white reflects that heat back into the atmosphere as well. So you look at something like this and you go, what could possibly exist in an area like this? I love this shot. This is actually a shot from the furthest south that I've ever been, which is about 68 degrees, something like that. So 2 degrees below the Antarctic Circle. And I'm looking directly towards where the South Pole would be, which in this shot is around about 1,300 nautical miles away. And I'm looking specifically at a glacier called the Todd Glacier. Yep, they even named a glacier after me down there. No, that's not true. And it turns out there's another guy called Todd who's pretty famous, and they named a glacier after him, but I'll use the namesake. So we're looking at the Todd Glacier here. What could possibly exist down here? And the answer is quite a lot. There's quite a few different species that have managed to find ways to adapt and live down in the Antarctic, if only for the summer, perhaps. There is actually one mammal that survives there year round, a seal. But penguins certainly are quite comfortable during the summer, during the Antarctic summer. And during the Antarctic summer, depending where you are, it's going to be anywhere between -10 and maybe +5 degrees Celsius, something like that, around zero. And these guys are quite happy. In fact, I've seen plenty of examples of overheating penguins that are simply too hot. Their insulation and their down is so effective that they're overheating and they're trying to lose heat. So they're incredibly well adapted. On the left here, we have a chinstrap penguin, and then on the right, we have an Adelie penguin. And here we have some gentoos, again, sitting on the ice, quite comfortable. In terms of mammal species, we have, of course, my humpbacks, and then various seal species. So on the left here, we have the Weddell seal. The Weddell seal is the most cold adapted mammal on our planet. It lives in Antarctica year round, which is a huge feat to be able to do that. And on the right, we have a leopard seal, which is the kind of the ecological equivalent of a polar bear down south. One of the really key important differences between Antarctic and Arctic ecosystems is that there are no mammal land predators on the Antarctic continent. So no foxes, no polar bears, nothing like that. So if you are an animal living on the Antarctic shoreline, then you mostly have to be concerned about scavenging birds. There's not really anything else that can get you. If you're in the water, then there are things that can get you. Of course, there's the leopard seal, there's orcas, and so on. No sharks, it's too cold for sharks. And hey, sue me, I'm a humpback whale biologist. I'm going to put a couple of shots of humpback whales in here. So this is, again, another individual doing one of their terminal dives, showing me its fingerprint. Because of the huge abundance of whales that the Antarctic region had, there is all kinds of signs of previous whaling activity in the area. So this is a beach that whalers used to cut up whales. And because at the time the bones were not valuable to them, they simply left the bones on the beach to rot. However, because Antarctica is so cold, the process of rotting takes very, very much longer. So these bones are probably at least 100 years old dead. And who knows how old they were when they died. So these are probably bones of animals that lived a very, very, very long time ago. And again, as a biologist coming down here and seeing this amazing plethora of whale bones, it's been just an extraordinary experience. Both from the point of view of science, but also from just the point of view of art. You know, I've gotten into photographing whale bones to see if I can capture their majesty. This is a jawbone of a blue whale that I found on an island called Half Moon. All kinds of seabirds in the area. Different seabirds are capable of working down at different levels in the Antarctic. Both these species you'll see relatively far south. Interestingly, once you get to the Arctic Circle, most of the bird life stops. You might see the odd penguin, but it seems to be a limit for them. They don't seem to be able to go too much further than that. And actually, one of my favorite birds to see on the trip, which are the albatross, don't even make it past the convergence. These are animals that seem to need to live in slightly warmer areas. They might dip down a little bit to feed, but then they go straight back to above the convergence. Switching to the Arctic, again, plenty of whale bones. We have good populations up there of beluga. This is a beluga skull and skeleton. We also have bowhead whales. This animal is an animal that is still currently whaled by indigenous peoples up there. It's essentially an Arctic version of the right whale that we have here in the Gulf of Maine. That is also threatened, but the indigenous take on this population is considered to be so low that it's sustainable. And it's also the acknowledgement, the permission for this hunt to proceed is done under the guise that whaling for these cultures is incredibly important. It's part of who they are, part of their identity. As I mentioned before, there are no land mammals in the Antarctic, but in the Arctic there are. Here we have a polar bear and the muskox. You'll see that unfortunately the polar bear shot is obviously photographed from a very, very long far away, and that's exactly how I want it to be. Polar bears are one of the only truly merciless killers I've ever come across. They just kill and they kill and they kill, and they don't necessarily eat, they just keep killing. They are amazing predators, absolutely amazing. This particular gentleman here is patrolling the bottom of a cliff looking for birds that have fallen out of their nests. And of course, something else that's really, really different about the Arctic is its indigenous peoples. You know, unless you believe in conspiracy theories, there are no indigenous peoples in the Antarctic. The only people that are in the Antarctic are people that have got there through the process of science and research and exploration. But the various indigenous peoples of the Arctic, including the Canadian Inuit, are just absolutely amazing, amazing cultures, very interesting people. When I did the Northwest Passage a couple of years ago, I fully expected to be dazzled by the scenery and the animals. But it was the Inuit peoples that just totally blew my mind. It was a wonderful surprise, and I met lots of fantastic, wonderful people there. And of course, they are actively depending upon the local marine mammal population. And some of them approached me a little bit gingerly initially because they knew that, you know, as a marine mammal researcher, that perhaps I cared about these animals. This gentleman here, for example, very proudly showing on his back a jacket showing off the Alaskan Eskimo Whaling Commission. But we had a grand old chat, and you know, it's really important to understand the role that taking marine mammals has in these cultures. It's pretty much the only thing they eat, and it's very much part of their spiritual identity. So just a quick comparison of the two food webs. You'll see they're actually quite dramatically different. So here we have in the Arctic, you know, we have various land predators and seals and a lot of different seabirds coming down to the base plankton, which include things like krill, amphipods, and so on. In the Antarctic, the main predators are all aquatic, so the leopard seal, the killer whale, and so on, and then coming down through the penguins. There are no penguins in the Arctic. So there's no polar bears in the Antarctic, and there's no penguins in the Antarctic, in the Arctic, sorry. That said, there are birds that were very similar to penguins, and one animal specifically, the great murre, which is now extinct, that a lot of people liken to something being very similar to a penguin. It was, again, a sort of a flightless bird. But very different food webs in that sense. So we'll move on in the final section here just to talk very briefly about history and governance, and this is probably the thing I'm less qualified to talk about, but again, just to get a sense of what's going on, both ends of the planet have very, very rich histories and exploration. This is a shot of Robert Falcon Scott's party that were second to the South Pole in the race to the South Pole. Of course, they were beaten by Amundsen, and Amundsen, who got there first, left a flag on a pole with a letter attached to it, and it was addressed to Scott. And Scott, when he got there, read the letter and he said, if, you know, in case I don't make it, could you please send this letter to my wife? So not only had Scott got there second, but he'd been reduced to the role of postman. And you can see here, it's a pretty disconsolate lot. And I'm sure many of you know the story of Scott's expedition. It was doomed to failure. Some say from the very start, from the very methods that Scott chose to employ. And Scott eventually ends up perishing on his return from the pole, only tens of miles away from his next food depot. And a couple of years ago, actually, I was very lucky enough to visit the Scott Polar Institute in Cambridge in the UK, and got to read extracts from his final diaries. And they're extremely moving. So say what you will about him as an explorer, he was quite a human being. And then in the north, we have sort of similar figures. In fact, a lot of the figures involved in the Antarctic were also involved in the Arctic. They were bipolar, if you will. I think most people here have heard about Sir John Franklin, who was famous for his attempts to discover the Northwest Passage, and also famous for his disappearance. And no one ever knew what happened to John Franklin. Although we're now getting much closer to solving that mystery, we have found his vessels, and there's been a bunch of theories put out there, including the idea that perhaps he died from food poisoning because his ship was one of the first ships to take on provisions of canning. Canning had just started in that time, and they used possibly too much lead in the solder joints to seal the cans. So when they opened the cans had lots of lead poisoning in them. So maybe that was it. There's plenty of other possibilities as well. In the middle panel, we have Robert Peary, who is credited as being possibly the first person at the North Pole. Because the ocean is constantly moving, the actual location of the North Pole changes under the ice, as it were. Well, it stays where it is, but the ice moves on top of it. And unfortunately, Peary did not do a good job of documenting that he had got there. So a lot of scholars actually put Peary's accomplishment as doubtful, but a lot of people recognize all the amazing exploration he did. And this final chap on the right, I bet probably none of you have ever heard of, Wally Herbert, who is technically the first person to get to the North Pole, to walk to the North Pole. He's the first guy, and he did it in 1969. And many of you probably have no clue that that happened. The reason why you have no clue is because at the same time, we were landing men on the moon. And that story completely eclipsed Herbert's achievements. So there's really interesting history and mystery from that history on both sides of exploration. But now we get to the idea of how do we govern these places? And this is probably the piece that will be most interesting to carry forward for those of you who choose to continue on to the Camden Conference. Who owns Antarctica? That's a really interesting question. And how do we define Antarctica? As I mentioned before, Antarctica is a continent. So we could define it simply by its continental edge and maybe a few islands associated with that. Most people define Antarctica as everything out to and including the water of the polar convergence, which is going to be somewhat further out. And the most formal recognition of what Antarctica is comes from this thing called the Antarctic Treaty, which recognizes everything below 60 degrees south. So the answer to who owns Antarctica is a really complex one. This map, which comes from like a vintage level National Geographic magazine, you can see there are pieces of pie here. And these pieces of pie represent claims by different countries before 1957, 1958. So you can see there's a bunch of countries here, Norway, Australia, New Zealand, France. But up here, this is the most interesting set I find. You'll notice 3 overlapping claims between Chile, Argentina, and Britain. And there lies a rub, a big rub. These people do not like each other, and they are very hotly contesting who they think owns Antarctica. In 1957, it was declared the geophysical year. And as a result of that, from that came the Antarctic Treaty, which was essentially born out of the paranoia of the Cold War that was happening. Russia and America were very, very mistrustful of each other. Russia has this raging space program. They've put Sputniks up into space, and they're very concerned. Both countries are very concerned about what's going to happen to how we develop the Antarctic. So they came up with this ingenious system called the Antarctic Treaty System, which essentially says no one owns Antarctica. And the essence of the treaty was that all countries would rescind their claims on Antarctica, and we would put forth this continent as a place for peace and science. So this is not my image, I've borrowed it from a website, but it does very neatly mention all the main articles of the Antarctic Treaty itself. We refer to the Antarctic Treaty System because there's the treaty, and then there's a bunch of other supplementary pacts and laws that further define particular aspects of the Antarctic environment. But here are the main ones that are really important and central to the treaty. First of all, no use of the military. There is no military presence in Antarctica at all. And that's a little bit challenging because often countries' most efficient ways of moving people are typically military ways. So there is a little bit of use of military vessels to get people back and forth, but there is no permanent military station on Antarctica from any country. It is declared here, Article 2, as a place for science. And everything about Antarctica is oriented towards science and collaboration, international collaboration of that science, which is just absolutely awesome. And it's really a role model that hasn't really happened in any other place in the world, including the Arctic. Here's item 4, very important. Any territorial claims before the treaty are put on hold. They're not eliminated, they still exist. So if the treaty were abandoned, then we would be back to the old problem of who owns Antarctica. A nuclear-free zone applies specific to the land, and so on. So it's this experiment that's been running since 1958. It's been hugely successful. Most countries agree that it's a good thing. The countries that think that it's not a good thing are typically countries that haven't signed the treaty. And it is a relatively sustainable treaty, at least till around about 2048. Then there's kind of a sunset clause for certain aspects of the system, and things will be looked at again. And I think people are concerned that as our resources on this planet start to dwindle, there's going to be increasing pressure to look to other places to find those resources. So people are concerned that, you know, there could be a significant threat to the treaty in the next, say, 20 to 30 years. In terms of how the treaty is actually managed, it's managed by a bunch of different countries. The inner circle of flags here are the original signatories on the treaty, and therefore they have somewhat more powerful voting rights. On the middle ring, you have countries that have joined since the treaty was signed, and their access to voting happens by their demonstration that they're interested in science. And the best way to demonstrate you're interested in science is to put a station on Antarctica. So these are countries that have current scientific programs. And then in the outer circle, we have the so-called non-consultative bodies, which are essentially observers. They don't have a vote in that sense. So could we have an Antarctic treaty system in the Arctic? And the answer is no, we don't. And that is really a problem of geography. So again, coming back to this question, how do we define the Arctic? It's going to be different. In the Antarctic, we had the convenience of a continent around which we can draw red lines, or the politicians can draw red lines. In the Arctic, we have an ocean surrounded by a bunch of different countries. And you can see, you know, each one of these colors represents a different country with interest in the Arctic. Some countries are within the Arctic Circle, but don't have shorefront to the ocean. and others do have shorefront to the ocean. Greenland's an interesting one because it belongs to the Kingdom of Denmark. But of course, Denmark itself is actually nowhere near the Arctic Circle. So there's some interesting ideas about how we define the Arctic. There's a couple of models here for how we might define the Arctic region. Some say use the Arctic Circle, which would be 66 degrees north, everything north of that point. That includes most, but not all, of the countries that we're interested in. Some people say use the 10-degree isotherm. So the place where you have 10 degrees and the warmest month of the year, when it's 10 degrees, the warmest month of the year, let's use that instead. Okay, that's one definition. Others say use the tree line. Okay, so the tree line obviously extends so far, and then trees can't grow in that cold anymore. So then you move into the tundra, the so-called taiga and tundra of the region. Both those last two ideas are going to shift as climate change comes upon us. These last two definitions are disfavored simply because they're not going to be static. They're going to move from year to year as the Arctic warms. So how we define the Arctic is kind of difficult. And that has led to some issues about how do we govern Antarctica? You'll notice that each one of these countries sticks into the Arctic. And as a result of that, they have sovereign rights to some extent within the Arctic, not just the landmass, but also their sovereign waters, which in theory extend about 200 nautical miles out from their shorelines. So we have real claims here for areas of the Arctic that do belong to particular countries. That's different to the Antarctic, so it requires a different solution. There are surprisingly few equivalents of anything like the Antarctic Treaty System happening in the Arctic, perhaps because of that. You are going to hear about, I'm sure, in the conference, about entities such as the Arctic Council. The Arctic Council is probably the most natural equivalent of the Antarctic Treaty Secretariat down in the south. It's principally, it's not really, it doesn't have much political power. It doesn't have political teeth per se. It certainly has done a whole bunch of research on different issues. Those issues have mostly been about environmental. And you can see here its composition consists of all those countries that we talked about before that essentially have territory within the Arctic. And really important are the indigenous peoples. So something that's really good about the Arctic Council, or a really good principle within it, is a recognition of the indigenous peoples that live in these spaces that we are presuming to take over. And at least within this particular governing system, well, governing system is probably a strong word, but discussion panel system, we do have recognition that the indigenous peoples should sit on that panel. They don't have voting rights, however, like the rest of the countries do. They have to be consulted. If you look at the bylaws carefully, they have to be consulted about pretty much everything they do, but they don't get to vote and comment on what's going on. And then in addition, there's a number of different observers, NGOs, and so on that are on this. So this was established in 1996, and it's been going fairly well, although it is criticized as a body. It's criticized as a body that makes a lot of recommendations but doesn't do much. I don't know whether that's a fair criticism, but that is certainly something that you see out there. Because the Arctic Council includes all countries that have land mass within the Arctic, that's a little bit different to countries that have shorefront in the Arctic. So you might also see reference to the Ilulissat Declaration. Ilulissat is a location in Greenland. And this happened in 2008, and it just involves countries that have shorefront property on the Arctic Ocean itself. And they dedicated themselves specifically to discussions of how we manage the Arctic Ocean. So you can see here topics such as climate change, environmental protection, maritime safety and rescue, and in general, just this idea of trying to manage the area peacefully. This is a quote from Anders Samuelsen, who was at the time the Minister for Foreign Affairs in Denmark. This idea to try and create a region that is low tension, whatever that means politically. The only other governing institute that I can think of that might be important, that might come up in discussions, is this one, which might not appear to be initially relevant, but in fact it's highly relevant. This is the United Nations Convention on the Law of the Sea, which is something that's been going on since the late 60s, and it's divided into several parts. Actually, the US, interestingly, has not ratified this particular convention because they believe that certain aspects of it are against American economic interests. But they believe in principle in most of it. What does the Convention on the Law of the Sea do? It's interested specifically in how we manage water outside of sovereign territory. So I mentioned earlier on that most countries that have shoreline are allowed to govern up to 200 miles outside of their coastline, and that's what they would call their sovereign territory, or some people call that the exclusive economic zone of that particular country. What happens outside of that EEZ? Well, the idea of UNCLOS was to start to talk about how we manage what happens outside the EEZ, with this idea that there's perhaps minerals and different fuels, oil, and so on that we can extract at depth once you move outside of that region. Well, remember that the Arctic Ocean is an ocean, okay? And if you actually draw the 200-mile limit for all these countries, you can see here in the lower panel on the right-hand side there's a whole bunch of ocean that would technically fall under UNCLOS. Now, we've not had to worry about it up to this point because it's been ice. And so we can't access the ocean underneath that ice. But with global warming happening, that ice is disappearing. And so the Arctic Ocean is once again becoming Arctic Ocean. And at that point, technically by definition, a lot of the Arctic becomes high seas. And so we're going to have to think about how we want to manage those areas in terms of UNCLOS. So this could be a really interesting test of this particular convention. And so I will leave you with this last movie here, just to show you an animation done by NASA. You'll notice that throughout this talk, I've not talked about climate change that much. That's because I am a believer. In fact, I think that's even a weak word. Belief suggests that some people have cause not to believe. Climate change is happening. It's fact. It's absolute science. The science is incontrovertible. We know it's happening. And we know it's us. We know it's due to anthropogenic influence. If you go anywhere outside the United States, the rest of the world has made up its mind. And hopefully now within our own government, without being too political, we're starting to see a shift back to that belief system and trying to do something about that. Because of climate change, we know the Arctic is going to shift. If we don't do something to change how we're managing this planet, the Arctic is going to warm and the ice is going to go away. This animation shows that already happening. Okay, so this is an animation of everything, I think, up to 2016. What you're going to see here, I guess I'll talk about it as it goes on. You'll see two graphics superimposed on here. So first of all, this graph shows you the millions of square kilometers of ice per year along the bottom. Okay, and you'll see also behind it the animation of how the extent of the ice is changing. And you'll notice for the up to around 2000, not too much change. But as we move later and later, and we start to see the influence, we get some really, really dramatic downturns. And so as you can see, the Arctic is no longer ice. It is now becoming an ocean. And so we really do need to think about how we manage that. And that's the whole point of this conference, Arctic geopolitics. How do we manage this area now that's become available to us? It clearly has huge value. It has value in terms of its potential economic yield. It has value in terms of trade routes. The Northwest Passage is now open. The Northeast Passage is open. Different ways to get goods across from ocean to ocean that might be cheaper. And of course, let's not forget, we have multiple indigenous nations living in the Arctic that were there first. And we need to consider how we involve these in how we involve them in these discussions, and we need to think about how we treat them as equals in these discussions. So it's an incredibly challenging time. As an academic, it's an incredibly interesting time to me as well. So I'm sure within the next 10, 15 years, we're going to see some remarkable evolution in how we think about the Arctic. So I guess that's all I have to say. Thank you very much for bearing with me. And I think we'll turn it back over to Elliot, who will moderate the questions.
Great. Thank you so much, Sean. That was great. We have quite a few questions to get through. First question is, if you could talk a bit about why Antarctica is considered a continent rather than an island.
I'm not on the committee that names things in such ways, but I would imagine it's just simply the vast scale, just the vast scale of this place. And we're talking about somewhere that is way bigger than the contiguous United States. And we don't really talk about North America being an island, right? So I think it's just the vast scale of the place. It's isolation, and it's isolation both geographically and oceanographically and atmospherically. So I think that's what justifies calling it a continent.
Mm-hmm. Absolutely. All right, and our next question is if you could talk a bit more about ecotourism and how that has been shifting your work there in the area in general over the last several years.
Yeah. So I sort of hid that fact from you guys, but obviously a lot of the work I do down there, again, getting down to the Antarctic or up towards the north, it's done through me helping with ecotourism operations. So the idea is that by getting a berth on these ships, I get to do my science work while I'm on those ships, and I essentially sing for my supper. In that I guide people, I do lectures, I drive zodiacs, I take guests onto the ice and so on. It's rather like being a park ranger. When I first went down to the Antarctic in 2001, there weren't that many vessels down there, but there were a few. I would probably count maybe 10 or so different fleets that were working down there. I didn't have access to all of them, but that's what it seemed to be. But certainly in the past 20 years, there is an extraordinary increase in ecotourism activity. I think currently the Antarctic experiences visits from maybe somewhere between 30 to 35,000, maybe a little bit more, individual tourists per year. Obviously the COVID year was totally different. No one went down essentially. But that's an issue, right? I mean, we're taking people to a wilderness. So how do we govern that? And the good news is, and perhaps I'm the wrong person to speak about this because I'm part of the system, the ecotourism industry in Antarctica is very strictly governed by an organization called IATO, which is the International Association of Antarctic Tour Operators. And honestly, the restrictions that they put on us are so strong that many of them have been adopted as typical environmental protocols for the Antarctic Treaty System itself. So they are really, really tough on us, and deservedly so, because we want to preserve this wilderness. There is no IATO for the Arctic, and it's kind of desperately needed. And I'm wondering whether or not we're going to see IATO, just because of the skill set that it has, perhaps extending into northern polar regions as well. So perhaps eventually we'll have an IAPTO instead of an IATO. We certainly haven't seen anything at the same level of coordination as what IATO does. It is a concern. These areas are sensitive. And so we need to think very, very carefully about how we develop tourism in either region. But on the other hand, the value of that tourism, both economically, but also in terms of education and taking people to places so they can understand and treasure this planet and make good ecological decisions in the future, that's huge. And the impact that we have, I'd like to think is really, really important. So I'd like to think we're doing a good thing, but it does come at a cost, and we have to be aware of those costs.
Our next question is sort of related, is how has Canada's restriction on cruise ships affected the Inuit population in the Arctic region? If you have an idea about that.
Yeah, I'm not very well qualified to talk about that. I can only speak to my own experience as a member of a crew that visited the Arctic on board a vessel that was essentially an ecotourism vessel. We visited many Inuit villages along the way, and that was a huge eye-opener for me, and I hope for the guests that were with me, in that really I was fairly ignorant of those peoples before I went there. And I came back having fallen in love with their culture and the way they do things, and just an awful lot of respect for who they are and the lives that they live. They are an incredibly impoverished people. And to sort of see how they have to live their lives day to day was kind of a shock to the system, and an important shock. And the impact that we individually had on each village seemed very significant. Many of the villages, in fact, all of the villages had craft outlets, and they were selling their products to the guests who came ashore. They also had opportunities to play who they were. So, every visit involved going to the local town hall and watching various rituals and dances and songs, which very much part of their identity, which, from what I understand, the Inuit are only slowly starting to rediscover themselves after, being forced into certain sort of educational mode. They're starting to get much more independent than that. So I think there's obviously a spectrum of impact here. On the one end, you want to leave these people to do what they do, and you don't want to interfere with that, and you want them to stay the way they are. But on the other end, we can potentially provide a sort of a source of tourism economy, as it were, from which they can potentially prosper. And so finding that middle ground is really essential. And I'll just end this answer by simply saying, if any of you have ever gone down to St. Thomas in the Virgin Islands and seen how tourism has tragically changed the Virgin Islands in a very negative way. I mean, yes, the island has benefited hugely from tourism, but it's nowhere near what it was now before. It's a totally different culture. That is something we totally have to avoid. So how we do that is a very tricky path.
Yeah, absolutely. And now, on very different subject, we have a question about your humpback whale research and whether the algae that grows on their flukes affects the identification or makes it more difficult or helps at all.
It doesn't help because it changes from year to year. It's a living thing, so it moves on the skin, and sometimes it gets sloughed off, and so a whale that looked like that last year could look completely different in another year. So what you're really looking for is whatever is underneath that patterning, and sometimes the algae can obscure that. Just to go down this road a little bit, for many years at Allied Whale, which is the group that I have the privilege to direct at College of the Atlantic, we relied on the human brain to match images. So, we would have students sitting there with an image of the whale you want to identify and a catalog in the other hand, and you just scan through the catalog trying to find the right image. It turns out the human eye is really good at doing that. More modern times, we now have computing power that is capable of grabbing an image on a piece of paper, creating a mathematical algorithm as a result of that, and using computers to match these things. And that science has come a long way. So things like algae, we can teach the system to ignore. And what we're really more interested in is the general shape of the tail itself, in addition to the patterns on the tail as well. Yeah.
All right, and our next question is also about your research and how the seasonal changes in the polar regions affect when you're going to do your research and when it's best to go for that.
Yeah, okay. If you're thinking about going down to the Antarctic and you want to see whales, you need to go in January and February. That's the whale area, that's the whale season. When I first went down to the Antarctic, I went for quite a long time, and I was down there at the beginning of December, and there were very few whales. In fact, I think we saw maybe one or two the entire trip. Now, if you go down in January, February, in December, you will see many more than that. So certainly the successful recovery of the population means we're seeing more whales across a wider period of time. But January, February is still the sweet spot. And the good news is that, you know, we're like the whales. We don't, or rather the whales are like us. They don't like being down there in the winter. So they're only really down there at the same time that we're down there.
All right. And it looks like our last question in the chat, unless we have any more coming in, is about the Antarctic Treaty and how it affects the seas around it, whether it affects naval military's access and other access to the sea around it.
Yeah. So that's a great question. And I don't know the complete answer. I will tell you that the original treaty itself does not deal, it completely punted on the idea of managing the water around Antarctica. So the treaty itself just applies to the land. Now, but the Antarctic Treaty System, which is the group of all the other pacts that go along with it, there are various treaties within that will talk about how we manage those waters. So, for example, there's one called CAMLA, which is, I can't remember the full acronym, but the last bit stands for living resources. So essentially it helps manage aquatic resources in Antarctica. There's CCAS, which is another one that looks specifically at seals. And then there's also the IWC, International Convention on the Regulation of Whaling, which is now more of a conservation than it is a whaling organization, that also has some ideas about how to manage those spaces. So there are some limitations to that extent. In terms of military activity in the water themselves, in the water itself, you know what, I have to pass on that. I'm not certain. Certainly I've seen military vessels in the water within the Convergence because they're used as logistic vessels to get materials down to the bases. They don't step on, well, they might step on, but they don't stay on the island. So for example, the Chilean Navy is quite a common sight down in the Antarctic. But in terms of exercises, I don't see anything like that happening. Of interest, back in the Second World War, England was very concerned that the Germans might set up secret Navy bases on the peninsula. And so they launched their own operation to create a series of bases on the peninsula that could keep an eye out for these kinds of things. It was called Operation Tabarin. And those bases are still there today. Kind of cool.
Wow. Yeah, absolutely. I'll turn it back over to Erich now, and we can close everything out.
All right. Well, thank you. We had a few more questions that, you know, we'll look to get back to you. But thank you so much for Professor Todd, and also the audience for coming tonight. This was a great presentation, and, you know, it would have been nice to have been at capacity in the Holmes room where we could have had 50 or so, but tonight we were at capacity near our 100 Zoom capacity. So we had a great turnout and a great audience, and we really appreciate everybody coming to this, the event for the Southwest Harbor Public Library, and also for the run up for the Camden Conference. So thank you very much. Thank you, Sean.
Take care, everyone.
And stay safe, everybody. Good night.